Hello, Hampshire Chemistry. I got a helper today because I only have two hands. And so we're going to talk a little bit about a galvanic cell. Um, Last week, you guys saw some drawings of them, and it probably didn't make much sense off of the PowerPoint. But this is a U tube. And what is in a U tube is agar. All right, so that's this stuff. Agar, you can find it's in ice cream and stuff too. It's a thickening agent. Um, when you dissolve this in water, it smells like seaweed because guess where it comes from? Algae and seaweed. Also in this U tube, there's potassium nitrate. So this is called a salt bridge because it is a bridge of salt. So this is Chase Bowers, my fourth grader. All right, he is going to go ahead and put the U tube in these two beakers. Over here, we have a piece of copper metal. Over here, we have zinc metal. Chase is blocking the label, and I can't see what this is. What is that stuff, Chase?
Copper sulfate solution.
It's a little less than standard molarity. It's about 0.9 molarity. And we have zinc sulfate solution. So what side do you think he should pour the copper sulfate into for trying to make a battery here, galvanic or a voltaic cell? What side do you think he should pour copper sulfate into? What side, Chase?
The copper side.
Okay, go ahead. And we just have to make sure that it touches the salt bridge, the agar. Keep going, keep going, keep going, keep going, keep going, keep going. Hurry up, hurry up. Okay, we're good. All right. Then the other side, we're going to put the zinc sulfate in there. If you look very closely, absolutely nothing is happening. Wow. All right, so the zinc sulfate is going on the other side. Also remember, copper things have color, right? Cobalt things have color. Zinc things do not have color. So in terms of colored solutions, copper and cobalts are blue. Nickel solutions are green. Chromium solutions are yellow. Pretty much everything else is clear. So again, if you look really closely, absolutely nothing is happening. So what we need to do is we need to make a circuit, right? So we need to close the channel between the zinc metal and the copper metal to make electrons flow from one thing to another. The job of the salt bridge is to make it so your zinc ions can flow in or out of solution, and so your copper ions can flow in or out of solution while being neutralized, the charge being neutralized by this. And so if I hold these two pieces of metal, nothing's happening to me. It's like holding two ends of a battery at the same time. Very low voltage, right? Versus like a household outlet, which is 120 volts. This is going to be much less. So we have a voltmeter, and what a voltmeter does is it measures volts. So we are going to connect our volts to each other. As a human holds two voltmeter clips together, we actually conduct electricity through our body about 0.13 millivolts. So we're hooking this up to our voltmeter, and we have a reading, right? Our voltmeter says we have 1.03 volts going from the zinc to the copper, or maybe the copper to the zinc. I don't know yet. We'll talk about that here in just a minute. Chase, why don't you go ahead and flip those leads? And as we flip them, we get pretty much the same reading, but instead of being a positive reading, we get a negative reading. So it's a negative amount of volts being produced. So Flip it back to how you had it originally, Chase Bowers. And so if you look at the voltmeter, the red wire is actually connected to the copper, and the black wire is connected to the zinc, and we get a positive voltage. All right, 1.04. Can you can go ahead and clean all that up, bud. All right, so this is what my drawing looks like. So you can go ahead and hit pause on the video, see if your drawing looks like my drawing. It should. So we have zinc sulfate solution, we have our zinc, voltmeter, salt bridge, copper sulfate solution. So go ahead and pause it. All right, now that you've unpaused it, I want to talk a little bit about our, what is being reduced and what is being oxidized. So these are our standard reduction potentials from our homework last week. So here's our voltaic cell. Here's our standard reduction potentials, right? Here's our setup. So do you think that the zinc is being oxidized or reduced? Do you think that the copper is being oxidized or reduced? This is really the last thing we're going to do with this problem. So how are you going to subtract these two numbers in order to get the largest possible voltage? How are you going to subtract these two numbers to get the largest possible voltage? And remember, is it cat minus anode or anode minus cathode? Do you remember? So how are you going to do these? Remember, these are standard reduction potentials. Cat minus an. So it's going to end up being 0.34 volts minus negative 0.76 volts to give us, it should be 1.10 volts. That is at standard, right? That is 1 molarity solutions. The zinc sulfate's 1 molarity. The copper sulfate is a little bit less. All right, so the question I have for you then is, what is my fat red cat? What is my fat red cat? So the zinc is oxidized. It is my anode. And the copper is reduced. It is my cathode. So the copper is my fat red cat. The copper metal should be getting larger in mass. And then the opposite thing is happening here. So the copper is coming out of solution, attaching here. For the zinc is going from the bar to the solution. All right, so if I let this keep running and running and running, the concentration of the copper sulfate is going to decrease. The concentration of the zinc sulfate is going to increase. Increase. Okay, last thing then for this little blurb, which way are my electrons flowing from then? Are my electrons flowing from my zinc to my copper or from my copper to my zinc? Think about it. Electrons are flowing. You got a guess, Chase?
Nope.
50-50. Are the electrons flowing from the zinc to the copper or from the copper to the zinc?
Copper to the zinc.
That would be correct on opposite day, but it's not opposite day. Sorry, bud. The electrons are flowing from the zinc to the copper. All right, I hope all that made sense to you. Our next video is going to be shorter and about concentration cells and then we'll look at different ways that we can use this technology, which doesn't look very user-friendly, and turn it into a battery. Thanks, guys. Say bye, Chase.
Bye.